right, lesson 8, rational functions and graphs. So here in 8a, we're going to rewrite polynomial and rational expressions in equivalent forms. We're going to determine the quotient of two polynomials using long division to find slant asymptotes. We're going to analyze a function completely, a rational function completely. And then in 8b, we're going to start by writing a rational function given the graph. And then we're going to use the binomial theorem to expand binomial expressions. And then 8c, we're going to use transformations of functions to graph, and we're going to solve rational inequalities. All right, so I know this is lesson 3a at the top. There's just a typo thing going on there. But anyways, lesson 8a is rational functions and graphs. And so in this lesson, we want to fine-tune our techniques for analyzing the graph of a rational function. Let's revisit the procedure we developed in our last lesson and expand on those steps below. All right, so the first thing we're going to do is we're going to simplify our rational function in lowest terms by factoring. Then we're going to find the domain of the function. We're going to determine the x-intercepts, if any. So actually, before I do step 3, I'm going to come up here and I'm going to find the zeros of the numerator and the denominator. All right, then I'm going to go to step 3 and determine the intercepts of any of the graph. So remember, the x-intercept is going to be the zeros that are unique to the numerator. And then the y-intercept is just where, where we replace x with 0 and solve for y. Step 4, we're going to find the vertical asymptotes. Remember, those are the zeros that are unique to the denominator. And we're going to find the wholes. And so remember, your wholes are the zeros that are in the numerator and the denominator. They're the ones that are not unique. Then we're going to find the horizontal or oblique asymptotes. Oblique asymptotes are the same as your slant asymptotes. So we're going to find the horizontal because you can't have both, horizontal or oblique asymptotes. Then we're going to test for symmetry. We're going to determine where the graph lies above or below the x-axis by using the zeros from steps 3 and 4 to divide the x-axis into intervals. We're going to create a number line, kind of like we did when we were looking at any polynomial inequalities. And then we're going to graph everything that we found in step 8. All right, so let's try this. So example 1. All right, I'm just going to go through the steps. Step 1 says to factor and simplify. So we factor this. You can use your X box. Factor the denominator. You could use your X box. We can see that these are the same. Remember, because those are not unique to the numerator and the denominator, that's actually going to be where my whole is at. We'll talk about that in a few minutes again. And so simplified, we end up with x plus 4 over x minus 2. Step 2 wants us to find the domain. Now, in order to find the domain, you have to look at the domain of the original function, okay? And so we're really looking at the domain of this piece, or actually the entire fraction there, but remember, your domain is where your denominator cannot equal 0. And so I'm going to use its factored version since we already did it. It's x plus 3 times x minus 2, and remember, that cannot equal 0. So we just set them each not equal to 0, and then solve. And so our domain is going to be from negative infinity to the smallest, union, the smallest to the next smallest, and you keep doing that pattern until you get to your biggest, which 2 is our biggest, and so it's the biggest to infinity. Use a number line if you need to. All right, step 3. So in between step 2 and 3 is where I said I'm going to go find those zeros. So I'm actually going to do that here instead of step 3. So I'm going to go find the zeros of the numerator and the denominator. All right, so for the numerator, we're going to set our factors, the x plus 4, and, equal to 0, and the x plus 3 equal to 0. And so we'll get x is negative 3 and x is negative 4. And then we're going to do the same thing for the denominator, which really we just did because that was how we found our domain. but we're just going to set it equal to 0. So x plus 3 equals 0, x minus 2 equals 0. And so we get x equals negative 3 and x equals 2. And so remember that if they're not unique to either one of them, so it's in both of them, that's where our hole is going to be. If they're unique to the numerator, that's your x-intercept. And if they're unique to the denominator, that's your vertical asymptote. All right, so then step 3 says to find your intercepts. So we need to find our x-intercept, which we just said was when x is negative 4, so negative 4 is 0. And our y-intercept, which to find the y-intercept, remember we let x be 0, so I can plug it into the original function or my simplified version, the x plus 4 over x minus 2. So I'm going to use the simplified, so x plus 4 over x minus 2, so 0 plus 4 over 0 minus 2, so 4 over negative 2, which is negative 2. So my y-intercept is at 0, negative 2. Then step 4 says to find the vertical asymptote and the holes. All right, so our vertical asymptote that we already said was where it's unique to the denominator. So it's an equation, guys, so you have to put the x equals, okay? If you just put 2, you're not going to get credit. You need x equals 2. And then our holes were the zeros that were not unique to the numerator and the denominator, the ones that were in both. And we said that the x value is negative 3, but we know it's an ordered pair, so we got to go find that y value. Remember, you found the y value by plugging negative 3 into the simplified equation. So that's the x plus 4 over x minus 2. So negative 3 plus 4 over negative 3 minus 2 gives me 1 over negative 5, so negative 1/5. See, step 5 says horizontal and oblique asymptotes. All right, so horizontal asymptote, remember, is where's your highest degree, top, bottom, or both. Doesn't matter if we use the original here or if we use our simplified version down here. Either way, we can see that the degree is the same on top and bottom. So we know that means it's a ratio of the leading coefficients of the top and bottom, which would be 1 over 1. And so we get y equals 1. Again, it's an asymptote, it's a line. It's horizontal, it's y equals. You have to put the y equals. And then the slant, which is the same thing as the oblique asymptote. Remember, that's only when the degree of the numerator is greater than the degree of the denominator by 1. Since our degrees were the same here, that means there is no oblique asymptote. Remember, you can't have an oblique and a horizontal, okay? It's one or the other or neither, but never both. All right, remember though, if there was one, we would find it using division. All right, step 6 is symmetry. So when we're looking at a rational function, anything that's a function cannot be symmetric to the x-axis, because then if it was, it wouldn't pass the vertical line test. So we don't have to worry about that. So therefore, all we have to worry about is, does it have y-axis symmetry, or does it have a symmetry across the origin, which was also when we did that even and odd. So an easier way maybe to do symmetry when we're talking about the function here will be just to check, is it an even or an odd function? If it's even, remember, symmetric to the y-axis, odd is symmetric to the origin, and then neither would just mean it has no symmetry. So in order to find if it's even or odd, that's where we plug negative x into our function. And it doesn't matter if we use the simplified or if we use the original. I'm just going to use the simplified, so it's negative x plus 4 over negative x minus 2. And then try to simplify it if you can and see, can you make it look exactly like the original? Can I make it into this x plus 4 over x minus 2? If I can, it's even. If I can't, it's, if I can, it's even. If all of my signs change, then it's odd. And if it's a mix, then it's neither. Well, as we can see here on this one, that the x's changed sign, but the constants did not. So therefore, this is a mix, so this is neither. It's neither even nor odd, which means its symmetry is none. All right, and 7 wants us to do a number line. And on this number line, we include our vertical asymptotes and our x-intercepts. So I got this number line here, and so I can see I have a x-intercept at -4, and I have a vertical asymptote at +2. And then just like when we did the inequalities of polynomials, we pick numbers in each interval. We're going to plug it in to see what it's telling us about our graph. Will our graph be above the x-axis in that interval, or will it be below the x-axis in that interval? All right, so I'm going to pick some x values here. So let's say, let me change colors. I'll pick like -5, 0, and 3. And so I'm just going to plug that into my simplified function. So -5 plus 4 over -5 minus 2. Excuse me, -1 over -7. A negative over negative is positive. I'm going to plug in 0. So 0 plus 4 over 0 minus 2. Just 4 over -2. Positive over negative is negative. And then I'm going to plug in the 3. So 3 plus 4 over 3 minus 2. 7 over 1. Positive over positive is positive. All right, so now we're ready to do step 8, which is to graph. And so when I graph, the first thing I'm going to do is plot all my pieces. So I'm going to go through all my steps here and plot everything I can. So we can't plot step 1, that's just simplifying the rational function. Step 2 is just our domain, it's what we should see at the end. So step 3 is where we really start plotting. So we can plot our x-intercept at -4 and our y-intercept at -2. And then step 4, we have a vertical asymptote at +2. And we have a hole at -3 and -1/5. Step 5, we have a horizontal asymptote at y equals 1. No oblique asymptote. Don't have to worry about symmetry. So that's everything we can graph. Now, hopefully we can see to the right of the, to the left of the vertical asymptote, we can see what's going on with our graph because we could play connect the dot. And so we can kind of see and remember they're always shaped by the asymptotes. But what this is telling me in my number line that I created, it's telling me that from -4 going to -infinity, my graph is going to be positive. My graph is going to be above the x-axis. So you can see I'm at the -4 and I'm going towards positive infinity. I'm going to go up, and that asymptote causes me to curve there. Then we can see between -4 and +2, our graph is going to be negative. It's going to be all below the x-axis. Now you have to go through those points. So coming out of the -4, going towards the +2, I'm going to have to go through these points. So I got to go across that hole, through that y-intercept, and then the asymptote there is going to force me to go down. Okay, and it's not the greatest drawing, but do your best, okay? Then what we can see here, from 2 to infinity, our graph is going to be totally above the x-axis. So that means it's going to have to be up here in this upper section, and it's just shaped by our asymptotes. And so there is a picture of our graph. All right, example 2, let's try another one. All right, so going to do the same thing. So step 1 is going to be that we're going to simplify this. Now, I can't factor the numerator. It doesn't factor. All I can factor is the denominator. So I'm going to leave the numerator alone. And I can create as common factor out that denominator. right, then step 2 is my domain. And so for my domain, remember, my denominator cannot equal 0. So that 2 times the x plus 2 cannot equal 0. So you can either split it, or you could just, we don't have to worry about the 2 on the outside because it doesn't have an x. So if I just divide by it, then I know that x plus 2 can't equal 0, which means x cannot equal negative 2. And so I know my domain is negative infinity to negative 2, union negative 2 to infinity. All right, step 3. Now before I do step 3, this is where I'm going to do those zeros. So my zeros of the numerator, ooh, I can't factor, right? So I'm going to end up having to do the quadratic formula for it. So it can't factor. So let's see, I'm just trying to see if I have enough room here. So x equals, well, let me write up here at the top. So remember our formula for the quadratic formula, x equals negative b plus or minus square root b squared minus 4ac all over 2a, where it's always in the form of ax squared plus bx plus c. So my a is going to be 1, my b is going to be 3, and my c is negative 2. So x equals negative b plus or minus square root b squared minus 4ac all over 2a. So negative 3 plus or minus the square root of 9 plus 8, so 17 all over 2. And I can't break down that 17, so I'm going to leave that there. Then to find the zeros of the denominator, we've already done that. That was where the 2 times the x plus 2 was equal to 0. So we said we had x plus 2 equals 0, which then x is negative 2. We found that when we did our domain. All right, so we can see that we don't have any that are the same, so there are no holes. I have this that's unique to the numerator. So this is my x-intercept, both of them. And then this is unique to the denominator, so this is our vertical asymptote. All right, we don't have a whole lot of room on this one. I'm going to have to borrow some room here. So let's see, I'm on step 3, which is the x and y intercept. So the x-intercept, we know is where x is equal to negative 3 plus or minus the square root of 17 all over 2. Now we know we're going to graph that, okay? So that means that x is equal to negative 3 minus the square root of 17 all over 2. And x will equal negative 3 plus the square root of 17 all over 2. So if I put this in my calculator to get an estimation, this first one's going to give me about a negative 3.56 approximately. And the second one's going to give me approximately 0.56. So I went ahead and did that because we're going to graph it and we need to know where to graph it. So we have to get an estimation of it. And then we got to find our y-intercept, which we just plug in 0 for x. Excuse me. Remember, it doesn't matter if you use your simplified or your original. So I'm just going to use the original one. So 0 squared plus 3 times 0 minus 2 over 2 times 0 plus 4 gives me negative 2 over 4, which reduces to negative 1/2. So I know my y-intercept is a 0, negative 1/2. All right, step 4 is going to be my vertical asymptote and my holes. So my vertical asymptote, we already said, was what's unique to the denominator, so it's at x equals negative 2. And then the holes are what is in the numerator and the denominator. There were none, so there's no holes. All right, step 5 was the horizontal asymptote and the oblique asymptote. So if I look for the horizontal asymptote, remember we're looking for that highest power of x. It is on top. If it's on top, I had that little shortcut no to help us. Remember the N stands for none. But remember that might mean that we have an oblique asymptote because you can't have both. And so the oblique asymptote is the top bigger than the bottom by 1. It is. So either we're going to have to do long division or synthetic division. And this one is being divided by 2x plus 4. You can only use synthetic division when it's divided by x plus or minus a number. So the 2x ruins it for us. So we're going to have to do long division. Let's see. And I'm going to try to squeeze it in here. So we're going to take our x squared plus 3x minus 2, and we're dividing that by 2x plus 4. All right, so remember, divide your first terms. So x squared divided by 2x. I'm going to write this over here, but then I have to erase it in a minute, okay? So x squared divided by 2x. We end up with the 1/2, and it's x. So we have a 1 here, so we divide these. That's 1/2. X squared divided by x is x. So we have 1/2 x. We multiply that times everything on the outside, so by the 2x plus 4. So it's going to give us x squared plus 2x. Subtract it, so you're going to change all your signs. Oh no, I'm going to run out of room. Yep, I ran out of room. I was hoping. Let me see. All right, I'm going to actually, I guess, have to move it up here beside the problem at the beginning. I hate to do that to us, but I'm just going to have to. No options. All right, so let me rewrite the problem. So it's the 2x plus 4 on the outside. And it's x squared plus 3x minus 2. And so what we had so far is we said we knew that this was going to be 1/2 x. And we took that 1/2 x times the 2x plus 4. And that got us x squared plus 2. But we had to subtract, so we're changing the signs. So your first terms will always cancel. That leaves us with x minus 2. We got to divide again. So now we have x. Let me change colors here. We have this x divided by the 2x. So go back to where I wrote it earlier at the bottom. So x divided by 2x. Our x's cancel. We still have a 2 on bottom, so we have a 1 on top. So we have a positive 1/2. Multiply 1/2 times everything on the outside. And so that gives us x plus 2. Subtract, so change the signs. It gives us a -4 for the remainder. But remember, remainders don't count on the slant or oblique asymptote. So we found that our asymptote or oblique asymptote there is going to be, it's an equation, so it's going to be y equals, and we got 1/2 x plus 1/2. All right, then step 6 is symmetry. All right, so for symmetry, we're going to plug in -x for x. I'm just going to do it to the original. This gives me x squared minus 3x minus 2 over -2x plus 4. Some of them change signs, but not all of them. So this is neither even nor odd. So there's no symmetry. And then 7 is our number line. And that's kind of what they got us set up for here in this box looking thing. Okay, they kind of have it set up for us there. So I'm going to have to borrow some more of my space back. So I'm going to erase this. This just helped us with those zeros. I made it fit when I did my notes. Oh, no, sorry. When I did my notes on the paper y'all have, but I'm just not fitting on this one. All right, so up here I'm just going to create my number line. And I actually, yeah, so I'll create my number line right here. So I have my negative infinity, I have my infinity. Let's see, we said it's going to be our x-intercepts. So negative 3.56 and the 0.56 and the vertical asymptote at negative 2. So negative 3.56, negative 2.56. All right, then we need to pick a test point. So between negative infinity and negative 3.56, I picked negative 4. From negative 3.56 to negative 2, I picked negative 3. Negative 2 to 0.56, I picked 0. And bigger than 0.56, I picked 1. And then it just kind of has it set up for us. So what is the value of f of x when we plug negative 4 in there? So I'm going to do a little work over here. So I just use the original. I think it's just as easy. So we have negative 4 squared plus 3 times negative 4 minus 2 over 2 times negative 4 plus 4. And when I simplify that, I got negative 1/2, which we know is negative, which means it's going to be below the x-axis there. Then we plug negative 3 in, so I literally just put negative 3 where all my negative 4s were. We're going to work that out, and I got a positive 1, which is positive, which means it's going to be above. Then I plugged in 0. Which we got negative 1/2. Which is negative, which means it's going to be below. And then I plugged 1 in. So I had a 0. I just changed them all to a 1. And when I simplify that, I got 1/3, which is positive, which means it's going to be above. Now remember, we said they're going to alternate unless we have some even multiplicity going on, right? So make sure they alternate. If they don't alternate, you need to inspect to see why don't they alternate. All right, and let's go through and let's graph what we've got. So let's see. We don't worry about, we can't graph step 1. We don't graph step 2. Step 3, x and y intercepts. So negative 3.56, right about there. Positive 0.56, so right about there. Y-intercept is 0, negative 1/2, so right there. We have a vertical asymptote at negative 2. Just going through my steps here, and we said there were no holes, so I don't have to worry about graphing a hole. Slant asymptote is at 1/2 x plus 1/2. So remember that is just a linear function, so its slope is 1/2 and its starting point is 1/2. So we're going to go to the starting point on the y-axis at positive 1/2, and then their slope is up 1, right 2. And so I'm just going to put a kind of sideways dashed lines right now. So up 1, right 2. Okay, so if I go and connect them, the dashed line, and then down 1, left 2. So there's our slant asymptote. All right, and then we can see from our number line here, we can see that from negative infinity to negative 3.56, we said it's going to be below the x-axis. So your negative 3.56 is that x-intercept. So we're going to go down, going towards negative infinity, and we're shaped by that asymptote. from negative 3.56 to negative 2, we can see that we are above it. So coming out of the x-intercept, going towards that vertical asymptote, it's going to go up, shaped by the asymptote. Then from negative 2 to 0.56, we're going to be below. Now 0.56 is your x-intercept, so come out of it. Go towards the negative 2, and notice you have that y-intercept in there, so you have to go through it and then let it be shaped by the asymptote. And then from 0.56 to infinity, we can see it's going to be above. So coming out of the 0.56, going towards the infinity, we're going to graph above, shaped by that asymptote. And so there is our graph. All right, and then they give us one more to look at. I know you're getting tired of doing this, but we're going to look at this one last example, and then this video... Oh. Do I have that? Yes, I do. Okay, sorry. I flipped my page. I'm saying then this video will end. All right, so it's the same stuff, just more practice. So let's simplify this. Now remember, this one's going to be your x box when you factor. It's got to multiply to negative 10 and combine to negative 3. That's negative 5 and 2. So that would give us 2x minus 5 times 2x plus 2. And so this one reduces. So that gives us x plus 1. That's just a scratch out. Here we go. It reduces to give us x plus 1. So when we factor this, we have that 2x minus 5 times x plus 1. And then the denominator is a difference of squares, so x plus 2, x minus 2. All right, and we can see that nothing cancels out. So then step 2 is to find the domain. So we know we're going to set that denominator not equal to 0. So x plus 2 cannot equal 0. X minus 2 cannot equal 0. So x cannot equal negative 2. X cannot equal positive 2. So our domain is going to be from negative infinity to negative 2. Negative 2 to positive 2. And then 2 to infinity. Then we're going to stop and we're going to find those zeros of the numerator and the denominator. So the numerator, we know that 2x minus 5, oops, let me do this. So 2x minus 5 equals 0, and x plus 1 equals 0. So we get x is negative 1, and we get 2x is positive 5, which means x is 5 over 2, or 2.5. Okay, do the same thing for the denominator. So x plus 2 equals 0, x minus 2 equals 0, so we get x equals negative 2, and we get x equals positive 2. All right, we don't have any that are the same in the numerator and the denominator, so that means we have no holes. So these two are unique to the numerator, so these are our x-intercepts. And these two are unique to the denominator, so those are both going to be vertical asymptotes. All right, so step 3 said to find your x and y intercepts. So we know our x-intercepts were the unique to the numerator, so that's at x equal, sorry, I'm just going to write as an ordered pair. So we have the 5/2, 0, and we had negative 1, 0. The y-intercept, remember, is what we get when we plug in 0 for x. So I'm just going to use the original one there. So when I plug in 0, these will disappear, and so I'm left with negative 5. Over, when I plug in 0 on bottom, I'm left with negative 4, which is just a positive 5/4. So 0, 5/4, or you could put 1.25 if you wanted. All right, step 4 is with 4 vertical asymptotes and holes. So step 4, the vertical asymptote, we already saw was at x equals negative 2 and x equals 2. And then holes were what they had in common, the zeros in common, which they didn't have any, so it was none. Step 5 was your horizontal asymptote and oblique asymptote. So where's your highest power of x? Top, bottom, or both? It is both, so it's a ratio of their coefficients. So 2/1, which is 2. So we know it's going to be at y equals 2. Which means, because we have a horizontal, we can't have an oblique or a slant, so therefore it has to be none. The top is not bigger than the bottom by 1. 6 is going to be symmetry. So we're going to find f of negative x. I'm just going to use the original. So 2 times negative x squared minus 3 times negative x minus 5 over negative x squared minus 4. So this gives us 2x squared plus 3x minus 5 over x squared minus 4. Almost the same, but that 3x is different right there. So again, it is none. All right, and 7 is going to be our number line. All right, so I'm going to draw my number line here. Put my infinities. Let's see, it's going to be our x-intercepts, which are negative 5/2 and negative 1, and our vertical asymptotes, which are negative 2 and positive 2. So put them in order from smallest to largest. So negative 2, negative 1, 2, and 5/2. And so my test point, I'm going to use what, negative 3, negative 1.5, 0, 2.25, and let's say 3. All right, so I'm going to go through. I'm going to plug these in. So I plug in negative 3. When I plug in negative 3, I'm going to get 22/5, which is positive, which means it's going to be above. Now, yuck, I don't like negative 1.5, so I'm going to skip it for right now. I'm going to plug in 0. When I plug in 0, I get 5/4, which is positive, so it's going to be above. And yuck, I don't want to try to do that 2.25 because of the squared piece, so I'm going to skip it, go to 3. Plug in 3. When I do that, I'm going to get 4/5, which is positive, which is above. Now remember what we've said, knowing what we know, if we can't use a calculator on here to check the negative 1.5 and the 2.25, we know these should alternate. Don't just pick the first one though and say, oh, it's above, they should alternate, so it's going to be below, above, below, above. Because what if you were wrong on the first one, but your other two come out to be below or something like that, okay? So don't just assume. Find the ones that you can find. Then if you have to assume, you can assume if you have to. But, so since every other one is above and there's no multiplicity at these zeros, I'm going to go ahead and safely say that both of these were going to be below. All right, and so let's go ahead and let's graph. So we're going to start with our x-intercepts at 5/2, which is 2.5, and at negative 1. Y-intercept at 5/4, which is 1.25. Vertical asymptote at negative 2 and positive 2. And a horizontal asymptote at 1. No holes and no oblique asymptote. All right, so I can see here that from negative infinity to negative 2, we said our graph is going to be above. So from negative infinity to negative 2, it's going to be above. Negative 2 is an asymptote, so we're just going to be in that upper portion and just shape it by the asymptotes. Then we can see from -2 to -1, it's going to be below. -1 is an x-intercept, so come out of it, go towards the -2. So you have to go down, shaped by that asymptote. From -1 to 2, we see it's going to be above. So -1 is your x-intercept, so come out of it. You notice between -1 and 2 is our y-intercept, so make sure you go through it. Shaped by your asymptote. And remember, it's okay to cross that horizontal asymptote as long as it crosses in the middle here, okay? We'll talk about in B or C, we'll talk about how do we know it crosses. But it's okay to cross in the middle. The horizontal asymptote is just dealing with the end behavior. We won't cross it on the far left or the far right side of our graph. And then we can see from -2 to 2.5, we're going to be below. 2.5 is the x-intercept, so come out of it, go towards the 2, shaped by that asymptote. And then from 2.5 to infinity, we're going to be all the way above. So come out of the 2.5 because that's your x-intercept, go towards infinity, and you're shaped by that asymptote. And there is our graph. Whoops, sorry about that.